Hi, let's use Descartes' rule of science to find the zeros of this polynomial function. So if we draw a chart right here, positive, negative, and imaginary zeros, we can find the number possible of each of these types of zeros by considering the sign changes of the coefficients of f of x and f of negative x. So if we want to figure out the number of possible zeros for positive zeros, we just look at the coefficients of f of x, and we see where are our sign changes and how many. So right here we have a sign change, so that's one sign change. Next, we look at the coefficients of f of negative x and determine how many sign changes to see the possible number of negative zeros that we have. So if we plug in negative x, we can just look at this and say, this term's going to be negative since we have an odd power here. This one's still going to be positive. This is going to be negative, and this will be negative still. So we have one sign change, two sign changes. So we have two sign changes. But these two zeros in the negative category can also be imaginary, since imaginary solutions always come in pairs, and we have two here. We don't have this with one because we don't have at least two zeros in this category. But we can also have zero solutions here, one solution there for sure, and then we'd have to have two imaginary solutions. So these are our possibilities, and you can see that within each row, these always add up to 3, since the degree of our polynomial is 3. So let's find some zeros. And in this case, it's best to start off with finding positive zeros, since we know for sure that there is one that exists. So if we look at all of these coefficients and write them down for our synthetic division to find zeros, we can see that if we add all of the coefficients up, we get 0. So that tells us that if we plug in 1, we get 0. So that tells us that 1 is 0. So now we have x minus 1 times this polynomial, which is x squared plus 10x plus 16. Now we just got to factor this. And if we do x plus 8, x plus 2, then we bring down our x minus 1, we see that we can totally factor this polynomial. And this is valid because it fits in this case where we have one positive zero and two negative zeros. So there we go.